So we are now testing a claim on this whole smiling versus neutral. We're going to use the same data. There's a homework problem on this too. Sample of 34 people who smiled during their hearing, 34 people with neutral expressions. And it says it's given below, but I'm going to show that in a spreadsheet. The values are a measure, again, of how lenient the judges were. We want to test the claim using a 4% significance level. Assume the population variances are unequal. It's kind of a standard assumption. And that the leniency scores are normally distributed. Either we need to know that or that the sample size is greater than 30 is the standard thing to know to use the formulas we're about to use. We want to give our final answers to 3 decimal places, and we're going to use the simple degrees of freedom calculation where we take the smaller sample size minus 1. All right, the data I'm going to put in a spreadsheet. This was from our textbook and from StatKey. I've highlighted here, so I'm going to copy that, and I'm going to bring it into my spreadsheet here, and then I'll reshare this out with y'all. Let's see, insert some space for it. I'm just going to adopt one I used earlier. So I need a couple columns left for this. There's my data. So if you're on YouTube, check out the description for the relevant links. In the text, they did box plots. Yeah, often when I'm looking at a new data set, I will take the data and make histograms and box plots just to kind of get a sense of the data. If a data set seems too skewed, then some of the formulas we're using may not be as accurate as they could be. And then we use what are called bootstrap methods, which we were using before. So we don't need to do that for this one here. I just kind of made the statement that, yeah, they're normally distributed enough. And again, that does need to be verified in reality whenever we're doing one of these for real. All right, so let's see, that pasted in kind of weird. Put the share in there. And there's a tab way over to the right of the many tabs, come on, that says to mean HT, is the one I'm working in here. This is the same sheet I've been using all day, last class, class before that. So I have 2 independent groups, and I'm looking at the means. So there's a group of people who are smiling, different group of people with neutral expressions. These are their leniency ratings from the judge there. This, I'm reusing a sheet I used before where I just typed in the numbers. I'm just going to delete those and start over. So remember, we humans make lots of errors, so we're going to use the computer to count to get n. I do the count function, and I'm just going to grab everything in this column because that's all that should be there is the data. 34, same thing here, count. Grab everything in this column. The nice thing about using the everything in the column option there is later, if somebody else gives me a different data set, I can just paste it in columns A and B, and these will automatically recalculate correctly. So we're building a reusable sheet that, if given the data, we can run a hypothesis test. Average. Whole column of data. Average. Whole column of data for the other one. It looks good. For the standard deviation, there are a couple of options. Start typing STD for standard deviation. The STDEV one works fine unless you copy this over to Excel, where the preference is stdev.s, which is the one I usually use. Never, ever, ever pretty much use the population version because we almost never have a population. All the numbers, same thing for the other column. And you will notice these numbers should look familiar. Right? This is the same data set we were working with last time, but I gave you the summary statistics. So in some of the homework problems, I just give you the summary statistics, and other ones I give you the data. Sometimes I give you the data and the summary statistics. All right. I also list the complicated degrees of freedom here, which is sometimes used. We're just going to go for the simple version, which says grab the smaller sample size and then subtract 1. Standard error, same standard error we calculated earlier. Inside of a square root, we square the first standard deviation, divide by the sample size, and then we add the square of the second standard deviation over the sample size. T. So the T, remember, let's go back to the notes. The T for a hypothesis test is always the sample statistic. For us, that's the difference in means here. Minus the null value for a difference in means is always 0. Divide by the standard error. So that's what's happening next. So let's double check my calculation there. Oops, wrong button. So here I take the difference in means above, mean 1 minus mean 2 is the standard approach there. And then minus 0, notice I didn't put it in there because when you subtract 0, nothing happens. So I just left that out. I'm just dividing by the standard error. I do need parentheses there. Without parentheses, it wouldn't do the correct division. So again, those parentheses are essential. P-value, oops, I forgot my hypotheses. Let's put those in there. This down a bit. Okay, so H0 is that there's no difference in means. So a bunch of ways I could write that. Let's see, the mu symbol would be nice. I think I have that. Oop. Somewhere, there's a mu over there. Let's grab u. Paste that in. In word processors, you can grab mu easily. In spreadsheets, it's a little harder. So we're just going to say for the nulls that there's no difference, meaning mu1 equals mu2 is the standard way to write that. Now, usually we want to look at an actual difference, not whether they're equal. So the alternative way is to say that mu1 mu1 minus mu2 equals, and then over here I'm going to put the 0. There. All right, what's my alternative hypothesis here? HA. Let's go look back at the problem. Because that will help us figure out what the heck the p-value means and whether if we have the right p-value. Wrong problem. That's the confidence interval. There we go. Test the claim that smiling rather than remaining neutral during a court proceeding will lead to a different punishment. Okay, it doesn't say more lenient punishment, it just says different. So it looks like not equal. This is a two-tailed test. See anything else? Nope. Yeah, so will lead to a different punishment. So either the null says it's the same leniency, same punishment, alternative says different. So it would be, do I still have mu there? Yeah, mu1 is not equal to, I don't have the not equal to, I'll have to go get that. Mu2. Somewhere back here, I have a not equal to symbol floating around. Here's one. And again, in a word processor, you can insert special symbols in a spreadsheet. You got to kind of copy and paste them. Or alternatively, Oh, paste order's messed up. There we go. mu1 minus mu2 is not. Oh, that came out bigger. Huh, weird. 0. Oops. So again, here we're saying there's no difference. Here we're saying there is a difference. Okay, so is a difference, that means I want a two-tailed test. So I have my t-score down here, and then here I'm just using the regular t-test. If I look back at my notes, what does the regular t-test tell me? Regular t-test says that's a left tail, all right? So what do I have going on here? Let's draw a little sketch to catch up with my calculation, make sure I'm doing it right. We assume that there is no difference. I just calculated a t-score of 2.04. That's a little more than 2. That's interesting. About 2.04. So 1 standard deviation, we're just around 2 standard deviations out here. So t equals 2-ish is about there. And so my p-value is out here in this tail right here. That's the p-value, or part of it. This is a two-tail test. So I have to reflect that over to the other side. And the combination of these guys is my p-value. So that and this is my p-value. So that's a positive p-value, so I should, for the p-value, be able to use the t.dist dot two-tail, because I have a positive t-score, and then it wants to know what my degrees of freedom are. So let's go do that. Or I could double the right tail. Now let's think about what the spreadsheet gives here. I accidentally used the left tail formula here. Oops, and that's the complicated version. I want that one. This one. Got a pretty blue. That's not pretty blue. There we go. I notice that this is 0.9. P-values are probabilities. They have to be between 0 and 1. That's almost 100%. That's like incredibly huge for p-value. That indicates I'm in the wrong spot, right? My picture, I should have a small number out and a small percentage in the tail here. So I accidentally did the left tail there. So I'm just going to change that formula. I'm just going to delete this one for now. All right, so I want t.dist dot right tail, and the computer says, oh yeah, I know about that. And it wants to know what's my t-score, and it needs a positive one, and it doesn't need a true, but it does need the degrees of freedom. We're using the simple version. So my p-value should be about 0.024. So that means each tail has about 0.012-ish. I'm gonna double check that in StatKey in a sec. In StatKey, I need that t-value. Copy that. Head over to StatKey here. I need not the normal dist, but I need a t-dist. Degrees of freedom is 33, right? 1 minus the smaller sample size in this case. And then I want a two-tail, and I can just paste in that number from my spreadsheet. And so oh, interesting. That looks 0.25, 0.025. Why am I getting a very different number? Oh, what? Interesting. That does not look right. Did I use the wrong formula?
The right tail.
Oh, I typed right tail instead of two tail. Ah, thank you, Tammy. Oof. Maybe I do need some caffeinated tea. Enter. There we go. So about 0.059. Remember, StatKey has a little more rounding going on, so the answer is going to be a little bit different. If I add those together, I get 0.05, which is kind of right at my threshold. The book recommends if it's exactly or almost exactly the significance level, then we'll reject it anyway. It's close enough. Here it's a little under 5% significance level, so I'm going to say reject the null. So this is less than 0.05, and so I should decide to reject the null hypothesis. Okay, what does it mean to reject the null? Well, that means the data supports the alternative. The alternative says there is a difference in leniency depending on whether you smile or not. That's kind of my conclusion. This right here is my decision.
At what point do you, make that decision though? Because, to me, I would look at that number and I'd say, yeah, but if I round up, it's going to be equal to
6.5. Yeah, and that kind of gets to before, earlier in the book when we talked about hypothesis tests, they talked about statistical significance versus practical significance.
Gotcha.
So is there a difference? Barely, but there is a significant difference. Is it a practical difference? Nah, sketchy whether it's practical or not. Does it hurt to smile? It didn't seem to hurt. So does this give us anything super concrete about smiling or neutral?
It might hurt if we teach criminals to do it and then they don't get put in jail because
yeah, but people are innocent until proven guilty. So if you're innocent and you smile, maybe you're more likely to not have a problem. The assumption here is it got this far, they're probably guilty, but again, that doesn't always happen. All right, so what's the conclusion? This is barely significant, but we're going to say it is. It's slightly under 5%. So then we just kind of, the conclusion is in plain language. Spreadsheet is not a word processor, so when I start typing here, it gets all weird. So again, I've mentioned this to some of you, it's not worth writing in a spreadsheet. Usually we'll write it up somewhere else. If you're dying to write in a spreadsheet, what you do is you highlight a whole bunch of cells and then you merge them. See, merge, and then you got to worry about alignment and text wrapping. So it's kind of a pain. You got to click 3 buttons, so that was hard. It wasn't too hard, but it is a pain. All right, so what's my conclusion here?
Clicking 3 buttons is pain.
It's pain. Yeah,
I think the monks from, the Dark Ages would strongly disagree.
Yeah, totally right. We're a little spoiled. So we have somewhat strong evidence, sort of strong evidence, mediocre evidence.
Mediocre, yeah.
Smiling versus a neutral expression during a hearing. Oh, I did not spell that right. Neutral expression during a hearing will lead to a more lenient sentence. It kicks in with the word wrap, and I guess I didn't need as much space as I grabbed. Okay, so we somewhat, if I can remember the word have again, we have, let's see, can I spell mediocre? Maybe, it's not quite right, but we're gonna go with it. We have mediocre evidence that smiling versus a neutral expression during a hearing will lead to a more lenient sentence. Okay, that's our conclusion. Boom, done. We did it. All right, we got enough time for another one. Oops, stop the recording. Where is that? Did I forget to hit record? It says it's recording.